So guys, this is our last days, and we got 122 days left. I want by the end of say March time, come March time, I want us to come into the end of March. I want us to start practicing past papers. So what that means is we're gonna be going into exam preparation mode. Okay, now the thing is with maths, you learn the concepts. It's easy. All right, it's easy. But if you don't practice, you're gonna forget it. And it's one of those things that you need to practice in order to get better at. You just can't get up and say, you know what, let me wing this. You know what I mean? It comes with practice. If you try to stick with the practice, you realize that you get better over time and you'll get better at a quicker rate if you was to practice all the time. Okay, so this is one of the final topics we have in graphs, quadratic equations and graphs. So the objectives we want to cover, we want to be able to identify the y-intercept of a quadratic on a graph and relate it to an actual quadratic equation. And we also want to be able to identify the roots of a quadratic on a graph and relate it to a quadratic equation. Now these are the two things that we're going to be focusing on, but we'll also see other key characteristics that are used when it comes to quadratics. So I want you all to take this down for now, and then after we'll go through those parts. Alright, so there are different methods to find out the roots of quadratic equations, right? So now when it comes to the y-intercept, that's easy, right? But for the quadratic equation, the biggest thing that we're going to look at is roots. So the methods to find the roots of the quadratic equations, we have factorizing, that's one. Two, we have using the quadratic equation. So that is something that we are going to be looking at today. That is something we are going to be looking at today, the quadratic equation. We're going to also have graphing. So you're going to see some graphs today, and you're going to be able to identify the roots from those graphs. Then the last one is completing the square. But today we're going to be focusing on number 2 and number 3. These two methods are going to be the ones we look at today as it relates to identifying the roots of a quadratic equation. So I want you to take this down before we continue. Alright, so the parts of a quadratic equation. Alright, so these are the parts of a quadratic equation. Now we have this one here, the axis of symmetry. So this is also referred to as a line of symmetry. This here is important because this basically shows us where the quadratic graph, also known as the parabola, so it shows us where this parabola has a turning point. Now, if you know about a line of symmetry, the line of symmetry is essentially the line that divides a shape so that it looks like a reflection of each other across that line. So imagine if this was a mirror and we are saying that this piece here looks like a reflection of this piece over here relative to this mirror. So that's why we call this the axis of symmetry. Now the y-intercept. So this is just like what we was doing with graphs when we had a y equal mx plus c. You guys remember that? Y equal mx plus c? What did the C represent? The y-intercept. Wonderful. So likewise, in this case, this here is a y-intercept. Alright, so this quadratic also has a y-intercept. So for this one here now, this here is the vortex. Okay, so the vortex could be either a minimum point or maximum point. So you'll see that in our next diagram, that it could be a minimum or maximum point. So that basically is the point where the curve changes direction. So as you can see, this one is like going down, however you look at it. This is where the point where it flips. Alright, so that's a vortex. Now these part here, we call these the x-intercepts, or the solutions, are most famously we call these the roots. So these here, we could call these the roots. Alright, so I want you all to take this down. This is going to be a visual representation of what you have to look for. So basically, whenever you're doing quadratics, these are some of the key things that are often highlighted in questions. What's the line of symmetry? If you don't have to find what's the equation of the line of symmetry, sometimes you have to draw the line of symmetry. And you could be asked, what's the vortex? Okay, what is the minimum point? What's the maximum point? So you tell the coordinates of that minimum or maximum point. What's the y-intercept? It's exactly where the curve crosses the line, okay? And then we have the x-intercepts, or the roots. So these would be where it crosses the x-axis. As you can see here, the roots are the points that cross. The roots are the points where the curve, the quadratic curve, crosses the x-axis. So take this diagram down. Very important diagram to visualize what we are talking about here. Alright, so this here now, right? We call this the vortex. Remember we said this point here, we call as the vertex. So as you can see here, it could either be a minimum point or a maximum point. So the vertex could either have a minimum or maximum point. So these would give you an idea of what a minimum and maximum point look like. So you could take this down as a example as to what the difference is between them. So as you can see, it's just one flipped compared to the other. All right, so the parts of the quadratic formula. Okay, so this is basically how the quadratic formula is usually expressed. It's expressed in the form y is equal to ax squared plus bx plus c. Now we know that when it comes to a straight line, it's y equal mx plus c. But for quadratics, it's y is equal to ax squared plus bx plus c. Now the a is a coefficient of x squared, which determines whether the vertex is a minimum or a maximum point. Now b is a coefficient of x, which kind of gives us an idea of where the line of symmetry is relative to the y-axis. However, what's going to happen is we're going to actually use that b along with a to be able to identify the line of symmetry, which is something that we'll do in our next lesson. And then we know that c refers to the y-intercept of the quadratic graph. So then we got this here. The sign of this determines the orientation of the parabola, the quadratic graph, which we will talk about next. And then this c is a value that tells us the y-intercept. All right. So what we're doing here is we are going through the theoretical part of the quadratic equation, the formula, and what it is. And then after, we'll dive into how to actually calculate stuff, how to identify the roots, as well as a y-intercept. So we're just trying to understand, what is this quadratic formula about? What are the parts of it? And how do we now have this to help us figure out what the roots are and the y-intercept? We kind of already got an idea what y-intercept would be. It would be this number that's by itself here with no x on it, just like the y equal mx plus c. Okay, so let's talk about this coefficient a. So coefficient a in a quadratic formula, when a is positive, the graph will have a minimum point. So let's look at this graph here on the right. So this graph here on the right, the equation is y is equal to x squared plus 4x plus 1. So now what is happening here is that we have x squared and we are trying to figure out what is the number next to x squared. So because we don't see any number here, we know that the number here is basically 1 multiplied to x squared. Okay, because remember, when we are comparing it, we are saying ax squared plus bx plus c. So a in this case is 1, so a is equal to 1. B is equal to 4, because remember we're comparing what's next to the x, so it's positive 4, so b is 4, and then c is equal to positive 1. But what we're interested in here is in the a, and a is equal to 1. Not only is a equal to 1, a is a positive number because 1 is positive. So once a is positive, the graph will have a minimum point. So as you can see here, this graph here has a that is positive and it has a minimum point. Does that make sense? All right, good. So when a is negative, the graph will have a maximum point. So if you look at this graph here, this is fx is equal to that, which is the same as saying y now is equal to negative 2x squared plus 4x plus 2. So we know that based off of this, the first thing is ax squared, right? So a is equal to what? What is a equal to? 1. Not in this case. What's next to the x squared? What number is next to x squared?
Do you mean the equation or the actual?
So we're looking at this one here. What's next to the x squared here?
2.
Negative 2. So that means a is equal to what?
4.
Negative 2. Yeah. So then this part here now, this part represents bx. So what is b equal to? 4. Lovely. And what is c equal to then? Nice. So plus c. So c is basically equal to 2. So as you can see here, the value of a here, I'm not concerned that it's a negative 2. I just like the fact that it's a negative number. So because it's a negative number, I know that it has a maximum point. So as you can see here, this graph has a maximum point. So it has a maximum point here, and that happens when a is negative. And in this one, we had a being positive 1. So we notice that once a is positive, we have a minimum point. So I want y'all to take down this text here for future reference. All right, so this diagram and this diagram was only to give you a visual understanding of what we meant by these two lines here. So take these down for now. And if you want, you could use these as an example to show you that this is negative, that's positive if you want to as well too. All right, we got it down. Well, in this situation here, what we're saying is when y is the subject of the formula, this is when this applies. Okay, so if you look at this, y is equal to ax squared plus bx plus c. The coefficient of x squared, which is a, is what we are looking at here. So in this case here, the coefficient of x squared is what? What's the coefficient of x squared in this case?
3.
Lovely. 3. Excellent. So looking at this now, the coefficient of x is b. So based on this equation here, because y is the subject of the formula, what is the value of b? What is the coefficient of x?
-10.
-10. Excellent. Now, what is the value of c in this equation, which represents the y-intercept? What is that value? Lovely. -8. Brilliant. Now, based off of this, we know that the value of this is +3. So my question is to you, does this graph have a minimum point or a maximum point?
Minimum point.
Minimum point. Excellent. How did you know that?
Because it's a positive number.
Wonderful, because a is a positive number. In other words, 3 is positive. All right, so let's look at this next side here now. So as you can see here, this one is arranged differently, but that does not change the fact that the value of a is always the one next to x squared, which is the coefficient of x squared. So what is the value of a in this equation here? -2, because look, that is the value next to x squared. The value next to x squared is -2. So our value for a is -2. What's our value for b? 11. Our value for b is 11. And what's our value for c? -12. Excellent. -12. So the thing here now is, how do we go about knowing if this has a minimum or maximum point?
I feel like this got a maximum point.
Why you think it has a maximum point?
Is it a maximum point because a is negative?
That's correct. That's it right there. So because a is negative, that is why we say that this has a maximum point. So remember when we spoke about this, we said when a is positive, we get a minimum point. And when a is negative, we get a maximum point. Just like this example, a was negative, we had a maximum. In this case, a was positive for +1, so we had a minimum. So with this equation now, since a here, we established that it's 3, that means it has a minimum because it's positive. And here it is negative, which means it has a maximum point. All right, so roots of a quadratic graph. So the roots of a quadratic graph represent the points where the graph touches the x-axis. So in other words, the x-intercept. The x-intercept would be referred to as the roots. All right, so at this point, y is equal to 0. So let's just say we had a graph here. At this point here, y is equal to 0. This is the value of where y is equal to 0. At this point, y is equal to 5. At this point, y is equal to -5, but here, y is equal to 0. Now, the next thing is the roots, okay? The roots. So the roots cross at the x-axis. So right here and right here is where this quadratic crosses the x-axis. So therefore, these 2 points would represent the roots. So in this case, the roots are -2 and +2. Okay, so -2 and +2. Okay, so -2 here and +2 here. All right, so take this down. You can use this as an example to show you where the roots are located. So let's look at the graphing method. So we spoke about 4 methods, and we said that today, when it comes to getting the roots, we're going to look at 2 aspects of it. We're going to look at the graphing part of it, and then we're going to look at the quadratic equation part of it. So first thing first, we have a quadratic graph here. As you can see by the curve, we have a minimum point, as you can see. So the minimum point is at -1, -4. So this right here is the minimum point. Now the question is, I want you to think about this. What is the y-intercept? We start off easy. What is the y-intercept?
-3.
-3. Excellent. And how did you know that?
Because that's where the line intersects on the y-axis.
Excellent. So that is the point where y-intercepts on the y-axis, right here at -3. So here is the y-intercept. So now the question is, what are the roots? What are the roots of this graph?
-3 and 1.
-3 and 1. And how did you know that?
Because the roots are always at 0 on the x.
Correct. So right here is the -3 and +1, which represent the roots of this particular graph. All right, so the roots -3 and 1, and the y-intercept is -3. That was fairly easy, right?
Yeah.
Lovely. So we could see that from identifying it from the graph. Now that we understand what the roots are and where the y-intercept is, it's easy to identify. And we know from this equation that the digit that represents the c also tells us the y-intercept. So in this case, our c value is -3. Okay, so it's -3, which highlights that the y-intercept is indeed -3. Now the next thing is, what's the value of b in this equation? What's the value of b? So we have ax² plus bx plus c. So let me put that down. So let's say we had it as this. What is the value of b in this equation? 2. Excellent. Because this b here represents this 2 here. Just how we knew that this y-intercept represents this guy here, we know that the b represents the 2. So now this a, what is the value of a here?
1.
1. Excellent. So we say that when we have x² by itself, usually it's 1 that's here. Now the reason why 1 is there is because anything multiplied by 1 is itself, so there's no point in listing the 1 there. So we know that it's just 1. So anything multiplied by itself is going to give us 1. That's why we leave it as x². So in this case, a is 1, b is 2, and c is -3. So the c tells us the y-intercept, and b along with something else will allow us to know the line of symmetry. But a tells us whether we have a maximum or minimum point. Now based on this a being positive, that tells us what kind of point do we have?
Minimum.
A minimum point, because remember, once a is positive, we have a minimum point. All right, so that's just tying back in what we did as well. Okay, so just trying to tie everything together. So we found the roots, we found the y-intercept, and based on these values, we realized that this -3 also shows us the y-intercept. And based off of this here now, we know that because a is positive, we have a minimum point, which we can see here. All right, so let's try it again. So we have this graph here now. I want you to assess it because we're going to look for the roots and we're going to look for the y-intercept. So process this graph, and then we're going to talk about that. What is the y-intercept of this graph? -2. Excellent. And we can see that because this graph crosses the y-axis at the point -2. As you can see also from the graph, it's -2 as well. From the equation, you can also see that it's -2. Now, what are the roots?
-1 and 2.
Wonderful. -1 and 2. Y'all got it, man. -1 and 2. Now, let's do a little comparison here again. So we said that y is equal to x² minus x minus 2. So usually if we have it in the form ax² plus bx plus c, let's start with the easiest one first. What is the value of c? -2. Lovely. Now, what is the value of a?
1.
+1. Remember, next to the x² we have a 1, right? Now b now. What is b?
-1.
Lovely, lovely. So b is -1. And we said that a, in this case, a is positive, which is why we expect to have a minimum point. Y'all getting it? Y'all getting there? All right, so we have another graph here. So I want you guys to assess this, and then we're going to try to identify what are the roots and the y-intercept. So take a look at it, digest it, and I'll ask you in a bit. All right, so looking at this, what is the y-intercept?
-12.
Lovely, -12. So as you can see here, we have -12 right here, which is where the line crosses the y-axis. And likewise over here, we have -12 on the equation, which represents the c part or the y-intercept part of the equation. What are the roots? 4 and minus 1.5. Excellent. 4 and minus 1.5. So as you can see here, -3/2 is the same as -1.5, and then we have 4. Then we got here -12 as the y-intercept. Now, if we go back to what we said earlier about the y equal ax squared plus bx plus c, what would be the value of c?
-12.
Lovely, -12. And what is the value of a? 2. So the value of a is 2. So what is the value of b?
-5.
-5. Excellent. All right, so I think everybody got this concept for this one here now. So now we want to use a quadratic equation to find roots, and then we want to use the equation of the graph to find the y-intercept. So I'm going to just have these pictures here to help you with that, but we'll go through it step by step. So let's see if we could get this done now. All right, so we have this graph here. So let's just pretend that we did not have this graph. So just looking at it first before we do our pretending, what are the roots of this graph here?
What are the roots, you said?
Yep.
-1 and 2.
And what is the y-intercept?
-2.
Lovely. So we are pretending now like we did not have this. So I'm going to say, what if I just knew that the equation was y is equal to x squared minus x minus 2. So we use here what we call the quadratic equation. So that's to find the values of x, where this equation is equal to 0. Okay, so in other words, I'm saying that I'm trying to find this here when y is equal to 0. In other words, where this graph touches the x-axis. So that's going to be where y is equal to 0. So if I'm saying that this equation here is equal to 0, then I could use that to find the values of x, right? So this is what it is. So let's just say x squared minus x, take away 1, equals to 0, meaning I want to find out what is the value of x on this x-axis for this particular graph. I'll use this equation called the quadratic equation, which goes like this: minus b plus or minus square root b squared minus 4ac over 2a. Now the question is, when you're looking at this, there are some letters that are kind of familiar, okay? Those letters are a, b, and c. Where do you think we're going to get those values from?
The equation.
From the equation. Lovely. So based on this, what is the value of a from this equation here? So the value of a is what in this case?
1.
1. Lovely. What's the value of b?
-1.
-1. And we know it from here. Okay, so this here is -1. So this here is a being 1. This here is -1, which represents b. And c is equal to what? -2. Lovely. Now I have all that I need to be able to use this equation to figure out the roots. Okay, so this is us trying to find the roots using the quadratic equation. This here is called the quadratic equation. So this comes on your exam. What you're learning to do now is how to use it. So the reason why I was having you identify A, B, and C all the time is because I know that we're going to be using it. So I wanted you to get familiar with identifying A, B, and C. So now, let's put this into this equation. So I'm saying that x, the values for that would be equal to minus b. So I'm replacing this b. So I have minus, and I'm replacing this b with the value of b here. So because b is -1, I'm replacing b with -1. Notice I still have my minus sign outside because it says minus b. So it's not telling me to just put minus 1. It's telling me that whatever b is, I have to put a minus sign outside of it. So in this case, I have minus and then the value of b, which is minus 1. Now I have this fancy expression here, which is plus or minus. Don't let this scare you. We're going to talk about this later on. All right, so for now, just look at it and say, okay, I'll learn what that is in a bit. Then now we have the square root of, notice how I'm putting things in brackets, especially with my negative sign. So b squared, we know what b is. What is the value of b?
-1.
-1. So -1 squared, then minus, in brackets again, 4, because I'm getting the 4 from here, times a. What's the value of a?
1.
Times 1 times c. What's the value of c? -2. All right. So now, all I'm doing here, this 4ac means 4 times a times c. That's why I have this here, 4 times a times c. And all of that goes over 2a, meaning 2 times whatever a is. So in this case, 2 times a, which is 1. So now I can work this out now. I can say that x is equal to, so I know -1 would turn to a what? Positive. So I'll have +1 plus or minus, and then I'll have the square root of, so check this out now. -1 squared is the same as -1 times -1, which is
1.
excellent, 1. So 1 minus, open brackets, now I have to work this out. So 4 times 1 is, then 4 times -2 is -8. Okay, notice that. So a positive times a positive is a positive, and a positive times a negative is a negative. Okay, so all of that now goes over 2 times 1, which is 2. Making sense so far, right?
Yeah.
All right, good. So next step now. So I'm going to say now 1, then I put back the plus or minus. Now I have to work out what's in this. So the square root of, I'm doing everything step by step so you could see. So 1 minus -8. If I put that in the calculator, 1 minus -8 is going to give me 9. So it gives me 9. Okay? And then that whole thing is going to go over 2. So you can back check this. 1 take away -8 gives me 9. Now this says, I need to do this again, but now I have to find the square root of 9. Okay, so the square root of 9 is going to be 3. So I'll have 1 plus or minus 3 over 2. So notice how we went from here straight down to this, straight to this, straight down. Now, what we need to do now is understand what this plus or minus mean. All this means is we're going to do 1 plus 3 first, and then we're going to do 1 minus 3. Okay, so we have 2 options here now. So the first one we're going to do is x is equal to 1 plus 3 over 2, and then we're going to do x is equal to 1 minus 3 over 2. So essentially what this does is it allows us to have the 2 options. So 1 plus 3 first, which is here 1 plus 3 divided by 2. And then after we have 1 minus 3 divided by 2. So then we're going to have x is equal to 1 plus 3, which is 4 over 2. And x is equal to 1 take away 3, which is -2 over 2. Now, 4 divided by 2 is 2. And -2 divided by 2 is -1. So as you can see here, 2 of these give us our roots. Okay, and from the equation, we know that -2 represents our y-intercept. So our y-intercept is -2. So notice here how I use the quadratic equation to work out the roots. So notice my roots here are the same as the roots that we saw here on this diagram. So if we did not have a graph, this is basically how we have to go about calculating it if we are using the quadratic equation. Remember, there are other ways that we could do the factorizing when that works, and we could do completing the square as well too. But in this case, we're using the quadratic equation. So I want you to take this down as an example, and then we'll try the next one together. All right, so same concept, right? So we have this here, a quadratic graph that we're going to be using to help us figure out what, or rather to back check our actual answers using the quadratic equation. So in this case, we know that the roots are negative 1.5. So let's say negative 3 over 2 or negative 1.5 and 4. And the y-intercept is negative 12. All right, so we know that obviously looking at this equation, the y-intercept is clearly going to be negative 12. So we got that out of the way, so we know that that's the easy part. The y-intercept, based on the equation, would be negative 12. Now, we are saying, as we did previously, that when y is equal to 0, we could use the quadratic equation to find the roots or the values of x when y is equal to 0. So we're looking at this equation, 2x squared minus 5x minus 12 is equal to 0. And we're using the same quadratic equation again. All right.
Excuse me, teacher, you get minus 3 over 2 for one of the roots. Wouldn't it be 1.5?
Yeah, so this is actually negative 1.5. So if you do negative 3 divided by 2, it's going to give you negative 1.5. So that was a good question. So that's how I got negative 3.2. I just negative 3 over 2. I just wanted to represent it as a fraction as opposed to a decimal, because once I finish this calculation, my answer is going to be as a fraction. All right, so we have this. What is the value of a in this equation? What's the value of a? 2. Lovely. What's the value of b?
5. Oh, shoot, negative 5.
Negative 5. Negative 5. And what is c?
Negative 12. Minus 12.
Lovely. So we have these values. So now that we have these values, we could use this equation, the quadratic equation. So then I could say that x is equal to negative b. So I know that we have minus, and here again we have a negative b, a literal negative b. So we put back the b here, minus 5. And then we have plus or minus the square root of b squared. So b squared would be negative 5 squared. So notice how I put this in brackets. Very important, especially when you're putting it in your calculator, to put it in brackets, because if you don't, you may not get the correct answer, because negative 5 squared, it has to be in brackets to get a correct answer when you put it in your calculator. So then now I'm going to subtract, and I'm going to say 4 times a times c. So 4 multiplied by a, what is the value of a? 4 times 2. And then we are multiplying that to c, which is what?
Negative 12.
Negative 12. Okay, so then all of this is going to go under 2 multiplied by a, which is 2. All right, so we set up our equation and we're ready to go. So we have x now, which is equal to minus negative 5, which turns to what?
Positive 5.
And that only happens in this case because this has a negative. If it did not have a negative and b was positive, we would have left it as minus 5. So now we go again, plus, minus, now the square root of negative 5 squared, which is 25. Negative 5 times negative 5 is 25. And then now we subtracting 4 times 2. So 4 times 2 is positive 8. 4 times 2 is positive 8. And then we're multiplying that to negative 12, which gives us negative 121. I mean, negative 96, sorry. All right, so 4 times 2 is 8. All right, so if I was to do it over here, 4 times 2 is equal to 8. And then it's going to be 8 times negative 12. So 8 times negative 12 is equal to negative 96. So all of that goes over 2 times 2, which is 4. So x is equal now to 5 plus or minus the square root of 25 minus negative 96. And once you put this in the calculator, you're going to get 121. So 25 take away negative 96 gives us 121. So you could always back check that on your calculator. So then now that's divided by 4. The square root of 121 is 11. Okay, square root of 121 is 11. That goes over 4. Now, you're not always going to get a whole number when you find a square root. There are times where you might actually get a different number. Okay, you might get a number with decimals. All right, so I'm just showing it to you with numbers that give you whole numbers to make it easy for you to be able to understand and focus on the concept. And as you grow and get better and you come across questions that have decimals, you're gonna know what to do. All right, so x therefore is equal to two things. I either have 5 plus 11 over 4, and then the next one is gonna be x is equal to 5 minus 11 over 4. So 5 plus 11 is 16 over 4, which gives us 4, which is one of our roots that we see here, right here, 4. So we know that's good. And then the next one, x is equal to 5 take away 11. So 5 take away 11 is minus 6 over 4. Now this could be reduced to, since 2 could go into both of these numbers, minus 3 over 2, or like we were saying earlier, negative 1.5. Because negative 3 divided by 2 is negative 1.5. So as you can see here, that is what this represents. So we know we are also good here. So we found the roots. We now know that the roots based on the calculation, we gotta have x is equal to 4 and x is also equal to negative 3 over 2. All right, so we have the roots of this equation using this process. All right, and we also identify the y-intercept from it by using the equation. So remember, this here was just our training wheels, so we could back check and make sure have that confidence that we did it correctly. If we didn't get these values, that means we would have to go over it again just to make sure. So I want you guys to take this down, and then we'll try one more together, and then I'll give you some to try on your own. So we know that for this particular one here, the roots, as we can see, would be here and here. So this root here is 2, and this one here is in the center of negative 2 and negative 4. So that one is negative 3. So the y-intercept now is equal to here. So it crosses the y-intercept at negative 6, which we can see here from the equation. So as we always say, the roots can be identified where y is equal to 0. So in this case, we said that x squared plus x minus 6, when that's equal to 0, we can find the roots. And we can find the roots using the quadratic equation. Okay, so in this particular one now, I want y'all to see when the b value is a positive 1, how it looks. All right, so in this case, what is the value of a? 1. So the value of a is 1. And what is the value of b? 1 as well. And what's the value of c? Negative 6. So a is equal to 1, b is equal to 1, and c is equal to negative 6. So now we could use this in this equation. All right, so what we will see is x is equal to minus b. So minus b, so this time b is just positive. So minus 1 plus or minus the square root of b squared. So b is 1. So 1 squared minus 4 times a, which is 1. So 4 times 1 times c, which is negative 6. Okay, and all of that goes over 2 times a, which is 1. So then I could say x is equal to negative 1 plus or minus the square root of 1 squared, which is 1, minus, open brackets, 4 times 1 times negative 6. So 4 times 1 is 4. Then 4 times negative 6 is negative 24. Make sure you're paying attention to this process. All right, then we go over 2 times 1, which is 2. Now notice, in this case, the b was positive, so we are left back with a minus 1. When we did it in this question, we had minus, because the b was negative, we also had a minus 5 here. So minus 5 turned it to a positive 5. So that's what happens when we have a b value that's negative. This negative b just swaps the sign. So since this was a negative 5, it turned to a positive 5 when we put it together. And now on this side, because b was positive, this made it negative. So let's continue here now. So x is equal to negative 1 plus or minus. Now the only reason that I have a minus in here is because a positive times a positive is a positive, and a positive times a negative is a negative. Otherwise, I would have left it with a positive number. So when it comes to these questions, you have to be very, very mindful of your signs. That's the one thing that trips up people when it comes to these questions. So when I do 1 take away negative 24, I'll get 25. And that's going to go over 2. So then now that's going to be x is equal to negative 1 plus or minus square root 25 is 5 over 2. All right. So just like we did last time, I'm going to split this. So then we're going to say x is either equal to negative 1 plus, well, we're going to say that x is equal to both negative 1 plus 5 over 2, and x is also equal to negative 1 minus 5 over 2. So in that case, negative 1 plus 5 is actually 4. So 4 over 2 is x, and then we have x is equal to negative 1 take away 5 is negative 6. So negative 6 over 2. So x is equal to 4 divided by 2, which is 2. So once I know that my number is going to give me a whole number is when I look to divide. If not, I try to keep it as a fraction. Okay, so I know 6 can be divided by 2. So negative 6 divided by 2 would give me negative 3. So I have two values of x, which represents the roots. So my roots are 2 and negative 3, as we can see from this graph, and we also identified from the graph. So we have two methods here that we're using to find the roots. We're using the graphing method that we have here, and we also have the quadratic equation. So we are using the quadratic equation as if we did not have a graph, so we could solidify that. And we also know that the y-intercept, based on the equation, the y-intercept is usually this value, the c value, which is negative 6. All right. So I want you guys to take this down, and I'll send you something now for you to start looking through so you can see if you are able to work this out using the quadratic equation. So yes, guys, so basically this is how we find the roots of a quadratic equation using graphs as well as a quadratic equation. The y-intercept is very straightforward. We just look at formula. Once y is a subject, then we would have the c value representing the y-intercept. And if it's on a graph, we just look for where the part where the curve crosses the y-axis. So the next thing we're going to learn in our next lesson will be the line of symmetry and the vortex. All right. So for now, let's work on this, practice this, get our confidence up with this. Remember, we not playing around with this exam, man. This ain't no play man thing here. We going to mash up this exam. Everybody going to get some ones on this exam, one day at a time.